Okay, let's get started. Absolutely, you're going to have two more. Got to keep you busy. So, you're going to have this circle to complete. Remember, I told y'all this is the starting point. And then we're going to go around this way. In fact, I think there's a mistake over here, and I keep forgetting to fix it. Maybe I did fix it. Anyway, let's find out. Let's do degrees first. So, 0 degrees. Scratch that off. An easy one would be straight up 90 degrees. All the way down would be 180. There we go. And down here would be 270. So 0 plus 90 is 90, 90 plus 90 is 180, 90 plus 270, what am I saying? 180 plus 90 is 270. So let's fill in some of the rest of these gaps. For example, if we only went up so much right here, that'd be just 45. Screw. 90 plus 45. And again, I may need to check because, like I said, one of these is wrong, but we'll find it. So 90 plus 45 would, 135. 135. So that's good. All right. And then 180. Okay, again, because like I said, one of these is wrong. We'll find it. 180 plus 45. I don't know why it's doing that. 225, 225, 225, 225. No, there's 225, so that's so far so good. 270, maybe it's this one. Surely it's 270. That's got to be right. Why is it doing that? 45. 270, that's right. All right, plus another 45. 315, 315, 315, 315. Ah, that's our mistake. Remember, I got this from the state, so don't blame me. Hey, but at least we found it. That one should have been 315. But I'm scribbling it out because it's off our list. And if we go all the way around, 360. Now, we're going to do radians. Radians is typically the ones with the pi. Okay? So, 0 for 0, so 0. Now, I'm just going to go ahead and break the ice for you. If we went all the way around to this side, to the 180, it's going to be pi. Okay? Well, if I went all the way over again, if half of that's pi, then I should have, that's right, 2 pi, 2 pi. Now, using that kind of logic, you should be able to fill out the rest. For example, if this is a whole pi and only went halfway, that's right, pi over 2. Okay, so that's a half, which means this half of a half would be a quarter. That's right, a quarter. Well, then if we added a quarter to the half, that's right. 3/4. I begin to think you understand. So if I went half, 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 this would be 3 halves, because you know the power of fractions. Okay, if I only went a quarter, okay, quarter from the whole, that's right, 5/4, pi, good. Quarter, remember reduce, 3 halves, okay. Add another quarter. I don't know why I'm putting 5, I've lost my mind. 7 pi over 4, that's a quarter, because if you add another quarter, that's 8 over 4, but 8 over 4 reduces to 2. Now, I'll go ahead and break the ice. Come next year, you're going to be filling in thirds. Okay, that's the wrong spot for a third. You're going to be filling in thirds and sixths. but that's next year. Right now, we're going to focus on this guy. So, what is the ratio? It's either going to be pi to 180 or 180 to pi. One or the other. Just depends on what you're doing, converting one way to the other. So, for example, if we have 32 degrees, make sure you have your handy dandy calculator or Desmos. I'm using this one for now. So if we're going degrees to radians, degrees is on top, so this is how you would want to think about it. 32 degrees times, we're trying to get rid of degrees, so put 180 on the bottom and put pi on top. The degrees, not zeros though, those are degree symbols, air quote cancel. So in your handy dandy calculator, I like using the Casio because it will simplify. 32, oh my goodness, 32 times fraction key pi over 180. And we get 8 over 45 pi. Boom. Now, using Desmos, you probably can't use the pi, so leave the pi off and just do the 32. 32 times, we'll put a 1 there in its place, the 180. See, 1 took the place of pi. We'll add pi back in a second. Hit enter, and reduce it to 8 over 45, and then we'll just throw the pi off. Okay. So same thing, 200 times pi over 180 because we're trying to cancel degrees. Get your calculator. I'm just going to leave that guy alone and just change the 32 to 200. 10 over 9. 10 over 9. Pi. Negative 40, no fret. You still put the 40 in there. We're still multiplying. Again, if you're using Desmos, so not a Casio, just do negative 40 times 1 over 180. Granted, you could just be dividing by 180, but I'm just trying to emphasize the fact that this should be a pi, but we're putting 1 as a placeholder. We get negative 2/9, so negative 2/9 over pi. Now, this is radians to degrees, so we're going to flip-flop that fraction. So we're going to have 7 pi over 8 times pi on the bottom now and 180 on top because we want degrees. Look what happens. The pi's cancels. Okay, so I know Desmos can handle this. So just multiply. We have our first fraction, which is 7 over 8 times. Now remember, those turns into 1, so it's like it's 180 over 1, but I'll keep up the same pattern as we did before. 180 over placeholder equals 315 over 2. Well, we do want degrees after all. Well, let's write this as a decimal. 157.5 degrees. Same thing for the 3/4. I'll go ahead and write that over here. 3 over pi over 4. Don't know why we have this box here. I don't know how to get rid of it. There we go. Times, let's see, where was I? 3 pi 4, 180. Remember, we want the pi's to cancel, so we'll put it on the bottom. Get your handy dandy calculator. And we're going to do 3 over 4 times 180 over, well, I forgot to put the fraction. But you know, it's just multiplied by 180, so I'm just going to hit equal. 135. Shebang. Ooh, this one just has a 2, no pi symbol. Totally fine, still treated the same way. 2 times the 180 over pi. I know there's no pi to cancel, but you're still going to use this ratio. Again, I'll plug it into the calculator. This time we're probably going to want a decimal anyway, so it's okay. We'll plug it all in, even in Desmos. So over pi equals, we'll round that, 100 and 9 will be a 6. So I'll do 114.6. Typically, when you do degrees, it's just one decimal place. Typically. Anyway, that's how you convert. Okay. Okay. Now get to work.